With over 40,000 students roaming the streets around Purdue University, minor and major traffic accidents are not a rare occurrence. Our client, the Purdue University Campus Safety Committee, requested to observe and analyze the intersection between University Street and West Stadium Avenue to come up with an idea to improve campus mobility safety. What makes this intersection unique is that it connects the Cary Residence Hall with the academic area. We, Maximilian, Anthony, Yun, and Juan Pablo, after collecting and analyzing over 4 hours worth of data, realized that the primary safety threat in this intersection is the heavy pedestrian traffic on the diagonal of the intersection. In our observations, we found that in a 30-second interval, as many as 75 individuals tried to cross the street diagonally, causing many people to congest the middle of the road, preventing bicycles, skateboards, and scooters from advancing without almost hitting pedestrians. And so, a model was created to address this. The model should adhere to the following criteria generated by the client's needs. 1. Solution maintains Purdue's aesthetic features. 2. Solution is appropriate for a campus community. 3. Solution must engage in informed design. And 4. Mobility safety is demonstrably enhanced by the solution.
The model was also created within the following constraints. First, solution may not affect the affordability of education on campus, which mostly concerns the university administration. And secondly, solution can be implemented with existing technology, materials, and infrastructure. One of the prior arts that we found was the flower pots idea. Placement of big flower pots on the entrance of the crosswalk not only fulfills the boulder's role, but also forces the pedestrians and bike users to slow down to go through the gaps between these big flower pots. It was limited, however, in that it decreased the pedestrian mobility speed and had the chance of bike users crashing into the flower pots, decreasing the user safety. Unlike the prior art, our selected solution fulfills the criteria and constraints. The selected design involves lining the diagonal of the intersection with LED lights that are shielded by protective covers on the ground. The LEDs will light up, indicating a separation of lanes. Also, the width of each lane will be different in different times. Description of how the lights will be modified will be explained later.
By counting how many of each type of pedestrian crossed the intersection during crosswalk times, we found that from 4:10 to 4:20, more pedestrians are crossing from Cary to Armstrong, and from 4:20 to 4:30, which is the passing time between classes, more pedestrians are crossing from Armstrong to Cary. And so, 10 minutes before the passing time, the LEDs will light up in a way that widens the path for people crossing from Cary to Armstrong, allowing for more efficient flow of pedestrian traffic. Here, the blue lights on the diagram represent the widened crosswalk for pedestrians crossing from Cary to Armstrong. During the passing time, the crosswalk for pedestrians crossing from Armstrong to Cary widens, allowing for a better flow of traffic heading away from Armstrong, as shown with the widened yellow lights on the diagram. And so, this solution would organize the diagonal crosswalk to allow for a better flow of pedestrian traffic at times of heavy traffic flow.
Besides substantially improving the flow of pedestrian traffic, it also scored the highest from all of our models on our weighted decision matrix, scoring the highest on both the enhanced mobility and safety criterion, and thus providing additional evidence of this model successfully meeting the main criteria. Despite the higher cost compared to the other models, our calculations determined that if the cost were to be divided amongst all students, we would only see an increase of $0.08 in our tuition. One significant limitation of our model is that it does not consider the pedestrians crossing diagonally from the other two starting and end points. Because of this, these pedestrians may interfere with the pedestrian traffic on the main diagonal. One possible solution would be to ignore the limitation. The pedestrians following the yellow paths will need to slow down to go past the pedestrians. However, that would not cause any accidents because of the crowd that is walking in a line. One of our trade-offs included the desertion of inexpensive solutions in return for better mobility safety enhancement. Despite our LED lane model not scoring the highest in affordability, it scored highest overall. Hence, we concluded that a higher cost would not outweigh its other features, especially its high safety score.